Okay, finishing up the notes. We saw last time that a longer wire causes a higher resistance because more energy is needed to get the charges through. And remember, resistance is the ratio of how much of a voltage drop there is. So essentially how much energy is being dissipated per charge divided by how many charges are going through. So longer wire, more energy needed to get charges through, means a higher resistance. Let's look at each of these variables in turn. What happens if you have a thicker wire? If you have a wire that has a greater cross-sectional area, that means it's thicker, its radius or diameter, or well, both really, are bigger. Well, what would that cause? If we look at the equation here, so the other one makes sense because if L gets bigger, R gets bigger, okay? If the thing on the numerator here gets bigger, R must get bigger. What if the denominator gets bigger? Doesn't that make this entire fraction smaller and decrease the resistance? It should. And the reason that this should lower or decrease R is because if you have a thicker wire, well, guess what you now have? You have space for more charges. I can't really demonstrate that on this simulation, but think about it. It's like saying I want to take a 2-lane highway and make it a 4-lane highway. You now have more room for more cars. You can accommodate a higher traffic flow. So since you have space for more charges now, you have a lower resistance. Before we get to resistivity, let's deal with the temperature, the hotter wire. Now you might think that a hotter wire means those charges are going to move faster, and therefore there should be less resistance because you can have more of a current flow. And it is true that things move faster, especially small things, when they're warm or hot. But think about it, if they're moving more, aren't they going to collide with the walls more? Aren't they going to collide with the other charges more? Matter of fact, that's exactly what happens. If you have a hotter wire, you can think of this as causing more unwanted collisions between charges due to their speed. And this will cause a higher resistance. So that's why things don't work as well when they get overheated. It's because literally the resistance is going up and the charges can't flow anymore. You don't have as big of a current, and that causes things not to run. Now, the opposite can also happen when if your cell phone gets really cold, then it doesn't work. That has to deal with other electrical phenomena that we're not going to get to. Last but not least, what happens if you have a more resistant material? And this one's kind of self-explanatory. A more resistant material means it is harder for charges to move. And that leads to a higher resistance. So, turns out if we increase the resistivity, the length, or the temperature, the resistance of a piece of wire increases. If we increase the cross-sectional area, the resistance decreases. It's all right there in the formula for you. Okay? So, what I'd like to do now is talk a little bit about what I'm going to expect going forward. Okay? First, let me get this out of the way with homework. Some of your homework assignments in the future are going to be multiple choice. Not all of them, but some of them. When you have a multiple choice question, I don't care if it's mathematical or not, you need to show some sort of work. Something has to be written down. I don't care if it asks you what ohms are equivalent to. You need to justify that somehow. Otherwise, it's not fair that if you don't justify it somehow, that's my first step to thinking they may not be completing this honestly or by themselves. Or without looking at someone else's answers. So you need to justify your answers. You can do it right on the sheet provided. You can do it on a piece of loose leaf. I don't really care. Just please justify your answers. And I will continue to make the comments about, hey, you left off units here. Hey, where's your equation? Hey, wait, this doesn't make sense. Okay? That sort of stuff helps you. Trust me. If I thought it didn't help you, I wouldn't do it because it takes me like 2 hours to evaluate everyone's work. Whereas normally it takes about 20 minutes, okay? It's much more time for me, but it is going to increase your understanding if I make these comments and you read them over, okay? So that's on homework. please, on multiple choice, please make sure you are fully justifying everything from here on out. Otherwise, I might not be giving credit for it. Okay? Okay. In addition, so there's homework. As we go through the circuits, this circuits unit, I'm actually going to give you a couple different times where I ask you, hey, you should go to this website. Okay, I showed you how to get there, and I think the second video, I'll provide links to it in Remind as well. But I really want you to start using this. You can build any circuit pretty much any circuit we will see in here. The one drawback to this is the resistors don't quite go up quite high enough for my liking. I mean, we can increase it a decent amount, but only up to like 120. But that's enough to, we could even do like scaled down versions of problems if we really wanted to. But it's good enough for us to get the basic concepts down and understand. I urge you, I implore you, go to this website. It's extremely, extremely useful. I was talking with my friend who is a physics teacher down on Long Island, and we have both come to the agreement that there is no substitute for actually building circuits and getting that kind of hands-on experience. In a way, this might be better because more things are going to be illustrated for you here than with a real-life circuit. Okay, this is a very, very useful tool. Okay, so I urge you to, whenever you have questions or you're thinking like, well, is this right or not? Open this up. You can basically, like, all the answers, you can construct all the answers on here. Okay, you can tell exactly what should be happening and what shouldn't be happening. So I urge you, please take a look at this website. It is extremely useful. If there are any other questions at any time, please do not hesitate to get a hold of me. Circuits is usually a great unit for most people. And I really haven't said that in the past about any of our other units. The mechanics stuff, they usually go fine for most people, but it is a little challenging. Circuits can be challenging, but I usually have people doing extremely well with circuits once they get the hang of it, okay? If you have any questions at all, please don't hesitate to ask me. Hope everyone's doing well, and I will see you soon.